Hello teammates, it's Mr. Ninini. This is the solution for FRQ 10, and I did something different. I looked at your responses before I shot this, and so I got an idea of where we need to work. First, so the first part was pretty good. It's actually, this whole problem can be solved with the first law of thermodynamics. Many of us went to the ideal gas law. I don't think you got to do that. So we're given some values. We're given a graph. Be careful. Watch the way the axes are marked. Right? You're looking at cubic centimeters, not cubic liters. Pascal's still good. First one, pretty good. So we're looking from, when you're reading something like this, it's a little tricky. It's always final to initial. So what this is telling you, it's telling you from final is state A, initial is state C. So that's a little tricky. That's worth reviewing, because that bit us in part B double I, and I'll get to that. So we're told we've got our change in heat. We've got our work. So our change in heat minus our work, 565 joules. That's good. That's good. So again, there's a subtlety. You notice how different that is? Well, you didn't see where I wrote. There you go. You see how different that is? State C to A, state C to A to B. See how that arrow isn't there? That's pretty tricky. You got to read this just the opposite way. Just like here. So this is going from A to C. Final minus initial. So you're going from C to A. That was all right. That was all right. This one was all right too. Heat's removed from the gas, because along now they're telling us in order A, B, C. Along pressure decreased at constant volume from A to B. Then volume stays constant, pressure is decreased. So you know work is done on the gas at a constant pressure. State A is at a higher temperature than state C, so heat must have been removed. So that one looked pretty good. Here's where we came off the rails, was part double I. And don't be frustrated. Again, we're still learning. This isn't one of those, if I get this right, I'm good. We're still learning. So here we're going state A, B, C. So because internal energy is a state condition, before we went from C to A, now we're going, and our internal energy increased because our pressure and volume increased. And recall the internal energy is a state condition based on the temperature, which is then proportional to your change in internal energy. But this one, it's reversed. This one, we're going from state A to C. And so we're going to change the sign on that. 565. Subtle point. But worth doing. Now we're going to, first law of thermodynamics, we're going to solve for Q. We're going to subtract our internal energy from each, change in internal energy from each side. We're going to end up subtracting our work, because our work is, I'm sorry. Let me show what I did. So I subtracted work from each side. So I ended up with change in U minus work equals Q. That's how I got that. So work is indeed positive, because recall our paradigm for looking at work. If work is done on the gas, our internal energy increases, so we treat that as positive. As work is done by the gas, we treat that as a decrease in internal energy, and we subtract it. So here we go. Negative 565 because we're going the opposite direction. Negative 75 because we subtracted it from each side gives us negative 640 joules of heat. So 640 joules of heat are taken out. Now if you got that negative sign right, if you got a BI and you saw what that was, and you're in the ballpark, right? We're just gonna fine tune. I would be cautious to jump right into PV NRT if you're dealing with the state conditions with internal energy, work, and heat. You don't have to go there. It's good. So that was let me come back to. So this first part was 1 point. That next part was 1 point. This was 2 points. Identify how much work is done on the gas. Easy money. We actually needed it to solve up here, didn't we? So I could have worked the order a little different. Easy money. Work done by the gas. So now we're looking. Now we're looking CDA. We're going this way. CDA. We didn't. I'm sorry. I was thinking something totally different. I was still up here. Watch units is what I was trying to say up there. Watch units here. Negative 150. So work done by the gas. Negative. Again, look at your terms. Your work in terms of internal energy. Is heat added or removed from CDA? You're going to look at the first law of thermodynamics. I recommend you always write your equation and work from there. Since changing U is positive, you identified that up on the first part, 565, and work is done, Q must also be positive. So 565 equals your heat minus the work done. You're going to solve for Q. You've added 715 joules of heat. It's good. Send me a question. If you got questions, I think this is worth looking at. Don't be frustrated. We're still learning. Thanks, teammates.